Hi guys, thank you for joining. This is the Oracle Machine Learning Office Hours. Today we're going to be doing the Oracle Machine Learning feature highlight, the new OML Notebook templates for machine learning feature extraction. So as always, my name is Marco Sarancibia. We have Mark Hornick and Sherry LaMonica. So any kind of questions you guys might have, make sure to please put them in the Q&A, and then we're going to make sure that we answer any questions you might have. And the questions might not need to be about this session. We are definitely open to any questions you guys might have as well about the product and anything else. All right. So then today's feature extraction. So to talk about that portion, we're going to be checking real quick on the next sessions that we have already in the calendar. And then we're going to go into the feature extraction that you guys can follow along. So if you guys have access to Oracle Machine Learning, which is available on any of the autonomous databases, including the always free. So you guys can follow along with me and check some of the features in the demos that I'm going to show. All right. Now, after that, we have time for Q&A. But again, you guys can type your questions at any point. Right. So first things first, and these are the upcoming sessions. So today we're going to talk about feature extraction, dimensionality reduction. Okay. And then on the next session, we're going to be talking about the explicit semantic analysis. So that one is feature extraction for text, right? So that's going to use the ESA algorithm. So today we're going to be focusing more on the algorithms that do attribute importance, do dimensionality reduction, PCA, things along those lines. All right. So the next session then we have scheduled for February 10th, a hands-on. So a hands-on lab on the machine learning for Python, and we have a hands-on lab session for February 11th in Portuguese. Okay, it's the same time, 8 a.m. Pacific, 11 Eastern. But then in addition to that, we're going to be adding more sessions, and of course scheduling the feature extraction, the next ones, and the time series and things along those lines. Right. So to talk about feature extraction, there are several algorithms, right? Differently than before we talked about classification or regression, there are algorithms that do a little bit of a different things, right? So the feature extraction methods that we have, we include attribute importance. So we have a specific algorithm called the minimum description length. That MDL algorithm, what it does is going to look at your attributes and is going to try to say, okay, which of these guys have the most importance based on variability, right? And other methods inside that, looking at a target, right? So at this time I have a target. I'm going to actually be looking at the attributes themselves and see, how do things compare, right, in my data. Okay. So for example, if anyone has the same color of their shoe, right, then obviously that attribute has basically the worst meaning of all, right, to try to discriminate between good and bad customers, right, between customers that are going to buy something or not. So these algorithms look into that what is the variability, what are the kinds of things that are there, so that they can try to say, okay, this is better attribute than the others, right? And then the other portion of these algorithms, right, for the feature and extraction methods that we have, then these are algorithms trying to do transformations or translation or rotation of the original attribute axis, right, and a decomposition of the original variables into groups of variables that are much better, right, and that can, instead of using 150 or 2,000 variables, right, you're going to be using 5 columns, right, 10 attributes to describe the variability, right, inside your data set. So those are PCA, singular variable decomposition, non-negative matrix factorization, expectation maximization as well, because we use that for attribute dimension reduction, and I'm going to show you guys an example. And then we have the CUR matrix decomposition as well, and then the explicit semantic analysis, which is for NLP, right, and information retrieval, and that's what we're going to see the next time, right? So because there are so many methods, I mean, we're going to not be able to go into all the demos of all of them, right? That's a lot to go through. So we're going to be talking about a few of them. So attribute importance, then the idea of the attribute importance, as I mentioned, we're going to try to look at the relative importance of the variables, right? In particular, the MDL that we're going to see has actually a predictor with a target. So it's going to look like what is the relationship between one at a time. That means one attribute versus the target at a time, right? That's going to be too simplistic for sure, but at least gives you an initial idea, right? So it is going to be very interesting to run this guy. And what OML brings right to the table with that is we have an automatic data preparation, so you can have missing values. We support partition models, so we have all of these things, right? So you can take all of that capability, normalization and binning, it's done for you. And then we show you that relative metric indicating the attribute performance, right, between these attributes, right, or the importance between them. And then to make sure that you have negative values saying this guy does not really contribute at all, or just adds noise to a potential model. Now, again, this is one method, right? There is one method of doing those things, right? The singular value decomposition is just a different method. It actually applies a transformation on top of your data. So it's going to work with the axis, right, of all of the different attributes, and it's going to look for the composition of that into rectangular matrices, right? And then it's going to show you what is known as the singular values, right? So it's going to show you, hey, these are the singular values, which you're going to be able to then understand those as the variance captured by each of the singular vectors, so that you can actually yourself then decide, you know, there's a cutoff point. So I'm going to get only the attributes that have this kind of contribution to these singular vectors, right? So that's part of what we do as well. In our side, we can support, you know, tall or and skinny solvers. We have a wide stochastic solvers, right? And we have traditional SVD if you want, right? So depending on the data set size, you can definitely use just the traditional standard SVD. And then we also provide the PCA scores. So the principal component scores are going to be part of our SVD implementation. Okay. And finally, the NMF. I did show you guys, this is the late 2020, when I was doing the 101 on feature extraction. I showed you guys that when I was playing with this, the NMF was actually one of the best methods to capture the correct attributes to actually use in my model. So I'm going to do again another 101 session, so another series of 101s. We're going to be showing a bigger demo with everything in it, right? But this is basically doing that. So it's, again, extracting attributes, converting those attributes. It looks to the attributes, but then it's going to run a decomposition similar to SVD, but it does the dimensionality reduction at the end of the day, looking at these kinds of structures in the data. So we have, as I mentioned before, then two options to access the templates. So if you guys can please go ahead and open up your Oracle Machine Learning if you're playing and using yours. And then what you have here then is directly access to the examples, right? So either from the quick actions menu on the left or on the right-hand side, and when you click on the hamburger menu, you get to the examples, right? Now, in this case, there is no such a thing as a feature extraction selection directly, right? So what you're going to do is if you do ATTR, right? If you type ATTR in the search box, you're going to find that we have two attribute importance methods using MDL. The left one is for OML for Py, right? Python. The one on the right is OML for SQL. And then the one on the rightmost there is the attribute importance using the expectation maximization. Okay. So I'm going to show you guys these three there. Okay. Then if we do, instead of typing that, we type dim, that's going to show you the dimensionality reduction notebooks. So we're going to have the SVD one, we have the NMF one in SQL, and then we have the SVD one in SQL as well on the top right there, right on the rightmost side. So the one on the left is the Python, but the NMF is only available in SQL, right, today. We don't have that algorithm yet in the Python API. And then finally, if you type EXTR for extraction, you're going to actually see the feature extraction using ESA. So that guy is using the explicit semantic analysis, right? So that's the one that we're going to see next time, because that's the one with the text component. So the ESA on the left for Python, and then on the right we have the feature extraction using ESA Wikipedia model. So both for Python and SQL, we have examples on how to use the Wikipedia model with it, right? So as before, basically we're going to select one of the notebooks, and then we're going to create a copy for ourselves, right? So we're going to click on Create Notebook, and then that guy's going to show up, and then we're going to, give it a name, give it a comment if you want, and just click OK, right? And then when we do that, that notebook's going to show up in our list of notebooks. All right? So far, so good? So okay, so let's go. So right here, what I'm going to do then is I'm going to click on the hamburger menu, and I'm going to go into examples, right? And as we mentioned, right, the first thing we were going to do is we're going to check on the ATTR, right? So the attribute importance, right? So we can see that we have the attribute importance algorithm. So we can really quick take a look at these guys. And because we have so many, right, you guys can click on one. So I'm going to click on the first one and click on Create Notebook, okay? But the other ones, I'm going to not create a notebook, and I'm going to just go straight to them, okay? So I'm going to say OK. And now on the top right, you see the confirmation. The notebook is created for me. So I'm going to click on the notebooks, okay? And we're going to go notebooks there, right? So this is the guy that I just created. So I can just click on it, right? And that's going to launch my notebook server, and then it's going to bring my notebook into the session. And then, as always, remember to check the interpreter, right? So if we want to run it, we always remember to check the interpreter bindings here on the top right. You click on it and make sure there is at least one of these guys selected, right? I have the medium selected, which is great. So I can just say, run all paragraphs, right? And I run everything. And by running it, I'm just making sure that everything is going to be there. If I want to change something, if I want to study better one of these data sets that have been created, that's the advantage, right? Is that this variable now, right, inside Python is going to be available to me, and I'm going to be able to look at the proxy, object and make changes if I need to, right? So data set, basically the supplemental demographics here. So lots of information about a customer, and I have a number of rows, right? So 4,500 rows, 14 attributes. These looking at just general information, specific columns. So I'm going to reduce the number of columns that I want to use for my attribute importance. Then I separate, because of Python, right? You want to separate the Y and the X, right? So you split up the Y, which is the target. So that's going to be affinity card here. And then there's a list of things that you could use, but these are very simple. For MDL, normally are very, very simple options, right? There's not a lot of options for you to worry about. So in this case, I'm going to do ODMS sampling, right? Disable the sampling. I'm just saying, please use all records, right? Because I know my data set is not that big, so I want to use every single record here on the analysis. And then I'm going to print out exactly the output, right? So I can see that there's an importance here, right? There is a data frame that is of the type AI mod importance. So let me print that out. So I print out the importance, and these are the importance. So these are the list of attributes, right? And then the list, the importance that they have to try to predict that affinity card, and then this is the ranking. Okay, so I see that, for example, printer supplies in this case have absolutely no importance at all. So I can probably drop all of these 4 last columns here, saying they have absolutely nothing to do with predicting that affinity card. Okay, and you can of course do a little graph or a little chart if you want to, right? Something like that. So it's very simple. Again, all we wanted to do was get an importance, right? An importance ranking on these guys, right? So if you go back to our examples then, and then again, ATTR, right? So you have the same exact process in SQL, right, for the MDL. And then you have the feature selection, unsupervised attribute importance, okay? So instead of creating a copy for myself, I'm just going to click it because I'm not going to run it, but I'm just going to visualize it, right? So just for visualizing it then, and then you got to see the note, right? There's a note here, important, right? If you wanted to create it for yourself, you have to run the OML Run Me First notebook, okay? So in the template examples, you have this guy, OML Run Me First, that you need to run because the data that we're using here requires that, okay? So in this case then, for our unsupervised process then, we drop a table if it exists, right? So we drop the sample settings here. We create a sample settings for our expectation maximization. Then we create our settings here. We add just a one cluster. So we're asking just for one cluster here. But what that's going to do is that it's going to build that cluster for us, and then it's going to have the importance of all of the attributes for that cluster. So when we create that EM model, and that basically we're doing that in SQL, right? When we create that model, then the attribute ranks are going to be available right outside here. So you get attribute importance value out of that view. So there's a specific view for us that is created when you build an expectation maximization model. And then that view here is showing us the attribute rank. And again, that's going to show us an attribute importance value that is relative again, right? So home ownership is the first one, number of mortgages is the second. Now, this guy is completely unsupervised, which means I did not give it the target. So that's giving me a little bit of a different twist, but I am seeing some other variables here, right, that have very, very, very low, and including first name and last name, which is good, right? So in any case, that's the EM. So we're using the unsupervised expectation maximization one, right? So going back to our examples, and now I'm going to switch to the dimensionality reduction one. So I'm going to type dim here, okay? So now for dimensionality reduction, you see I have different methods here, right? I have the SVD for Python, and then I have the NMF here for SQL, and then I have the SVD for SQL as well. So I'm going to go into the Python SVD one. And then I can see that's our SVD problem that I'm solving here, right? So this guy then, we're going to see, okay, there is this is the singular value decomposition. So I'm going to use the breast cancer data set that we have used on several of these processes before. And then the singular value decomposition algorithm here, right, that we're running. Then what we're doing is we're saying, okay, let's fit breast cancer. That's my input, right? That's this guy here, right? So the X and the Y, right? So that's basically, I'm taking the entire set of 31 input attributes, right? Including the target, and then I'm just passing everything there, right? And then you're getting basically, you're gonna say, okay, that's my input proxy object, right? My data frame, and then I'll give it a model name. So when I print out the model name, when it's done, this is what it's gonna look like, right? It's gonna say singular value decomposition, This is the model name. These are the settings that were used. So you can pay attention to this specific setting, which is the SVDS scoring, right? So our scoring for singular value decomposition has a PCA format that you can enable. So when you do that, we are actually going to show you the PCA scores when we do the scoring. So that's the way for you to retrieve the PCA components, right? The principal components here. So that's basically what we're seeing here. And then we see that the computed settings. So these are the number of features, attribute names, and then these are the attributes that we were using, right? And then that's the attribute ID. So you have the feature ID. So for feature 1, right, you have all of the coefficients for each of the attributes, right? And feature number 2 and etc., right? So, and then you can see now the importance of that feature ID, right? So these features are much bigger, right? Singular value than the next ones, right? Than the 2 and 3 and 4. So you could easily say, okay, you know what? Let me get the two first features representing a lot of the importance of this entire set of attributes, right? So you definitely do not want to touch any of the features that are down here, right? So with that in hand, basically what we can do then is we can look at, again, the singular values, right? Which is, we can easily do a quick computation here to see what's the percentage of the total, right? Of that value. So you can see that the top 2 represent, 93, 94 point something percent here, right? 94.2x percent of the total information, right, that you would have on your entire data set. So that would be very interesting and very smart to do. Potentially just use only the top 2 features. And then the dimensionality reduction, then, for example, what we're going to do here is going to take, as an example, the top 3 features. So we're going to just take the top 3 features, and then we're going to look in the other data set, right? And in the other component, what are our targets versus the top first feature, top 2 and top 3, and then we can see what are the values for each of those attributes, right? So we can then compare features, and then we can check, with similarity. We can display the coefficients for the PCA, and this time it's a PCA, right? Remember that when we said we wanted the PCA features out. So that's basically what this guy is going to do. So it's going to get all of the features, attribute names, and then it's going to give you the value, right? Because they were all numerical, right? You're going to get an attribute value of none, right? But if we had things that are, gender, location, region, zip codes, you're going to see those, the attribute name there, right? And then, so we want to do a prediction of principal component projections. So we can easily do that with our PCA projections in SQL. You can just use them directly like that. So you get you predict them and say as PCA project 1, 2, and 3, and then we can look at the projections directly there, right? So because we have the scores on the projected PCAs, we can just plot them, right? We can look at that and then bring the data locally and plot. So this is the left hand side has the original data, right? So we have the 3 top attributes there, and then we can see that what the SVD is doing with the PCA projections is just twisting this thing, right? Taking it from this distribution that you can see, and then making it a little more visible, more widespread, more flattened, right, onto each axis, so that you can actually see better the importance, right, of these attributes. And then basically that's the idea. And then finally, you can produce the U output, so you can see the index variable for each of the cases there, right? And you can do new parameters. You can refit the model. You can see the singular value decomposition help at the end. once you're looking at all the outputs, right? All the components that you wanna work with. Okay. So that's for the SVD side. So if you go back to our examples, then we have this guy here. So that's the NMF one, right? So this is the SVD on SQL. This is the NMF. So I'm going to click on this guy. And again, I'm not going to load one for me. I'm just going to look at real quick. And so on this one, again, you're going to use that same data set that we were using before. So you're going to see that the methodology is very similar. You're going to produce a model. You're going to create a model. There's no target here, right? So remember, there's no target that you're saying anything here, right? And then in the NMF, in this case, you're going to see, because the data set has some of these things, right? Marital status and gender and things like that. We're going to see that the coefficients here shown for each of the levels, right? For example, of that of the data set, right? Of your attributes, and then basically the idea is then you can check for the first two NMF features for each row, and that's something like this, right? So you can then check for the projections, okay? So you get the projections for the two top features. So what we're going to see when I go and do this again with the 101 for you guys is that I went and actually on top of this, I added machine learning algorithms, the classification ones, using these projections as input. So I was showing you guys that what you can achieve with those kind of things. Okay. So basically that's it. So these are the different ones that we have. The next time we're going to talk about the ESA. So the ESA ones are going to be the text-based wiki models, and we're going to see, the explicit semantic analysis ones. So hopefully that was useful. If you guys have any questions, please don't hesitate to ask them. And Mark, Sherry, any questions so far?
No, at the moment we are out of questions for the Q&A. One's coming comment from Doug. Looking forward to the ESA efforts, so that'll be good.
All right, excellent. All right, guys, so that's it. Thank you very much. I'll schedule the next session, and you guys should get a notice on email. Thank you very much, and have a great day. Thank you, Mark. Thank you, Sherry.
Thank you, Marcos.
Thank you, Marcos.